this lesson we will be sketching parabolas using factorisation. So let's jump straight into a question. Sketch y equals x squared minus 6x plus 5. Now the first step that we need to do when sketching a parabola is to actually just find the intercepts. So let's find the y-intercept by letting x equal 0. So y equals 0 squared minus 6 times 0 plus 5. That'll just give us y equals 5. Find the x-intercepts, we let y equal 0. So we'll get 0 equals x squared minus 6x plus 5. Now this is where the factorisation comes in. So let's use PSF. We've got a product of 5, a sum of minus 6, and factors will be minus 1, minus 5. So we know this will be 0 equals x minus 1, x minus 5. If we solve that using the null factor law, x equals 1 and x equals 5. Now, from here, we need to find our turning point. So we've got our intercepts, now we need to find our turning point. And the first step in finding your turning point is actually to find your axis of symmetry. So axis of symmetry. Now there's two ways you can find your axis of symmetry. The axis of symmetry will always lie halfway between your two x coordinates. So if you take the average of your two x coordinates, that will be the equation for your axis of symmetry. So let's do that. X equals 1 plus 5, our two x coordinates, divided by 2, 6 over 2, x equals 3. Now the other method you can use to find the axis of symmetry is using the rule x equals minus b over 2a, based on the general form of a parabola y equals x squared plus bx plus c. So for our parabola, we've got x squared minus 6x plus 5, so our b is minus 6, our a is 1, so 2 times 1 will give us x equals 6 over 2, which is 3. And I should, just to make that clearer, make this a x squared here. Alrighty, so we've got our axis of symmetry, x equals 3. To find the turning point, we substitute in our axis of symmetry, so x equals 3, into our original rule. So when x equals 3, y equals, what have we got? 3 squared. So x squared minus 6x plus 5. So minus 6 times 3 plus 5. So y equals 9 minus 18 plus 5. So y equals minus 4. Therefore, we've got a turning point at 3, negative 4. And now we can go ahead and sketch this parabola. Alrighty, so I've gone ahead and sketched this parabola. I've labelled the key features. Our turning point was 3, negative 4. Our x-intercepts were 1 and 5, and our y-intercept was 5. So we've got all the key features there on this parabola. Let's have a look at one more question. The rule for this parabola, sketched below, is y equals x plus a, x plus b. Find a and b and the turning point coordinates. Now, we've been given the rule in factorized form, and we know from this parabola what the two x-intercepts are. So straight away, we can write y equals x, this will be plus 3, and x minus 1. The reason why it's minus 1 even though the x-intercept is 1 and it's plus 3 even though it's negative 3 is because if we were to use this rule to find the x-intercept, we solve for y equals 0 and then that would give us x equals minus 3 and x equals 1. So therefore a is equal to 3 and b is equal to minus 1. Now we will need to go ahead and find the coordinates of the turning point. In order to find the coordinates of the turning point, the first thing we need to do is find the axis of symmetry. We can do that by taking the average of the two x-intercepts here, or finding the halfway point. So we'll get x equals minus 3 plus 1 divided by 2. So x equals minus 2 over 2, which is minus 1, which looks about right if we were to draw our axis of symmetry going through there, minus 1. Alrighty, then to find our turning point, we can substitute our x equals 1 into the rule that we found for the parabola. So when x equals minus 1, y equals minus 1 plus 3 minus 1 minus 1. So y equals minus 1 plus 3 will give us 2. Minus 1 will give us minus 2. So y equals minus 4. Therefore, turning point is at minus 1 was our x and minus 4 was our y.